everyone, how are we doing today? Okay. So we're starting, or we're not starting, we're deep into probability now. We've gone over the definitions, we've gone over calculating some basic probabilities, we've gone over the addition rule, and today, and we've even looked at expected value, and today we're gonna look at what we call probability models. Okay, and basically this is just a way to say some more applications or some more word problems that include probability. Okay, so we defined this once before, but we'll define it, well, we defined it a number of times, but let's look at complements, okay? Now, remember that if E is an event, then E complement, or E with a bar across the top, okay, is the new event of all outcomes not in E. Okay, so the best way to kind of look at this is to go back to something that we're familiar with, like a die or the coins. Let's look at a die. We're just gonna look at a single die, so roll a die, and I want the probability of getting a 4. Okay, so on the die, the probability of getting a 4 is 1/6. Everybody agree? Okay. Now, maybe you're playing some game, and if you land on 4, I don't know, you have to go back or you have to pay money or whatever it is. So you want to know the probability of not getting a 4. Okay, a 4 is bad in your case. Now, the easiest way to do this is to say, if 1/6 of the time you get a 4, then how often would you not get a 4? And like I said, the easiest way would go 1 minus 1/6. Take the whole set, take away what you don't want, and that will give you 5/6. Okay. The other way to do this would be to list out the different options. If you don't want to get a 4, that means you could get a 1, a 2, a 3, no 4, a 5, or a 6. So notice 1, 2, 3, 4, 5, 5 out of 6. So using the complement is an easy way to, keep from having to do more math, basically. So let's say that the probability of missing a flight is 19%. Okay, so you're gonna go take a flight. The probability of missing that flight is 19%. Okay, so find the probability you make the flight. Okay, so find the probability you make the flight. Well, in this case, you have to use the complement. So the probability of making it is going to be equal to what's left over here, or 1 minus 0.19, which will give you 0.81, or 81%. So if there's a 19% chance that you miss the flight, that means there's an 81% chance that you will make the flight. Okay. All right, so that's the idea of complements. And again, we've talked about complements. We've dealt with them when we're doing sets. So you've seen the idea behind complements, and you actually use complements on a regular basis without even writing anything down. But it's going to come into play in some of the formulas we're going to work with today. So what we really want to look at in this section is odds. Now remember, this class is all about how we use math in everyday life, okay? And a lot of times people misuse the word odds and mean probability, or vice versa. They say the probability, but they actually mean odds. Now, probability and odds are most definitely related, but they are not the same. So in our case, it's important that we understand that there is a bit of a difference to these two. Now, if you want to get into horse racing or that kind of thing, then you're definitely going to hear a lot about odds. But again, we're just learning about how things, the way that we hear things matters. So make sure you're using the proper words. So when we talk about odds, there are two ways that we can look at odds. So the first one is odds in favor. Odds in favor. And odds in favor is the ratio of success to failure. Okay. So it's going to be represented as a fraction, and we could write the fraction as S over F. Success over failure. Okay. Now the other one is odds against. And odds against is the ratio of failure to success, which means it's going to be failure, or F, over S. So right off the bat, we see that when we talk about odds, there are actually two different types, and which one are we actually talking about? So that really comes into play. When most people use the word odds, you know, like the odds are that I'm going to do something, they really have no idea what they're talking about, okay? So it's very important that we understand this, this idea here. So let's see what I have on page 662. Okay, so this says the probability of getting 3 heads when rolling, or that's not rolling, flipping 3 coins is 1/8. Find the odds in favor. Okay, so this is our first deal here. So this says the probability of getting 3 heads is 1/8. Now remember, when we do probability, this top number is success, but the bottom number is the total. Okay, so it's not success over failure. Probability is success over the total. So if we want odds in favor, what we want is success over failure. Now, we're still going to have this one success, aren't we? There's one way to get 3 heads, okay? Flip 3 heads. But if there are 8 ways in total, if one of them is a success, how many of them are failures? Okay, and that would be the other 7. Everybody agree with that? So you see, using the complement there, success and failure are complements. So together they add up to 8. Now, when we talk about odds, you are never going to plug that into your calculator. You will reduce the fraction, but we will never plug that in. So the odds in favor are 1 to 7. 1 to 7. So because it said odds in favor, and the 1 is the smaller number, it means it's harder to get 3 heads than something else, okay? Or than everything else. So odds in favor, 1 to 7 or 1/7. All right. Let's see. Now, if we're going to be doing this, okay, a lot of times when we're given a probability, they don't give it to us in its fraction form, do they? They actually give us a percentage. So we need to be able to deal with that as well. So we have 2 little formulas. if you don't really ever use the formulas, that's okay. If you can think it out yourself, it works just fine. So we've got the odds in favor formula. When we have probabilities is the probability of E divided by the probability of E complement. Okay, which is essentially what we did here. We took the number of successes and we divided it by the complement, which would be the number of failures, which was 7. So this is more, again, for if they're giving you your information in decimal form or percent form rather than fraction form. Okay, then that means that odds against is equal to the probability of E complement over the probability of E. Okay, so let me see what I have for this one. So this says the probability of an event is 45%. Okay. Find odds against. So this time we want to find odds against. And again, they've given us the probability of the event, but they've given it to us in percent form. So remember that we don't want, when we're doing odds, we don't want our answer in decimal or percent form. So we need to kind of go backwards on this. So I'm going to bring this down here and I'm going to say the probability of E is not 45%, but could it be written as 45 over 100? Is that another way to write 45%? Okay, do we agree? Okay. All right, now, we're going to need both of these, right? If we have the probability of E, we also need the probability of its complement. So if 45% of the time this event happens, then the complement would be 55. But again, we're going to write that as 55 over 100. So if we want odds against, okay, we're going to use that second formula, the probability of E complement over the probability of E. So we're going to take this guy, 55 over 100, and we're going to divide it by 45 over 100. Now, normally, but not always, normally these two denominators are going to be the same, okay, but not always. But remember, I know this is algebra here, that when you have this big old complex fraction, you take the bottom guy and you flip him over. Okay, so take the bottom guy and flip him over and multiply. And what ends up happening is the hundreds cancel out, which is nice. And now we have this 55 over 45. Now, if we were doing any other section, we'd get out our calculator and go 55 divided by 45, but not in this section. Instead, what we want to do here is just reduce. Okay, so both of these guys have a 5 in them. Does everybody agree? So if we cancel out a 5, there'll be 11 left here. And if we cancel out a 5 there, there will be 9 left there. So we end up with 11 over 9, or 11 to 9, okay, if we're talking about odds against. So the odds against are 11 to 9. So odds against means that failure comes first, which means there's more chance of failure than there is of success in this case. Okay. All right, get the idea there? So what do we have next here? If odds in favor to 2 that an event happens, find the probability of the event. So in this case, they've given us odds in favor, but they want us to come up with the probability. Okay, so remember, they're related, but they're not the same. So remember that probability is going to be success, but it's going to be over total. It's not going to be over just failure. Now, odds in favor, though, is success over failure, yes? So in our case, they're saying the success is 7 and the failure is 2. So what we need to do is to start plugging in pieces that we have. So in our case, we know the success is 7 from what was given above. But what we need to find out is the total. So together, success and failure should make up the total, shouldn't it? So if we add those two guys together, we should get 9, and that is going to be our total. So we can make a little note of that. Success plus failure gives us our total. Okay? And that's how we found this bottom number. Now remember, this guy is a probability, so we can plug this one into our calculator. 7 divided by 9. So this gives us 0.778. So if odds in favor are 7 to 2, it means the probability of the event is 77.8%. Okay, so 7 to 2 turns into a probability of 77.8%, okay, which is still a good chance. And again, we look at the favor. The favor is the first one. It's high, so it means there's a good chance. All right, let's see, that's the wrong book. What else do we have here? Sorry, I've got all these page numbers written in my notes, but I'm just making sure I find the problems that I am looking for. Okie dokie. So next we have horse racing. So when you go to the track, okay, I honestly have never been to a horse track, so I really don't know this, but this is, you know, what we see on television. When you go to the track, each horse has odds on it, okay? Now, when you go to the track, they don't tell you whether it's odds in favor or odds against, it just says odds. So the first thing is to remember that in horse racing, it's always odds against. Okay, so even though they just say odds, we have to assume against. So let's say that you are looking at a horse, let's call him Bouncing Bubbles. Has odds against of 18 to 1. Okay, so our horse's name is Bouncing Bubbles, and he has odds against of 18 to 1, which means with failure over success, this is going to be 18 failures to 1 success. So he's going to fail 18 times to every 1 win, which means, does this guy have a good chance of winning the race? Okay, he doesn't, does he? But we can actually put that into better terms by saying find the probability he wins the race. Okay, so find the probability of a win. Now remember, the probability is going to be success over the total. So his number of successes is 1, but what's the total here? What are we going to divide by? We're going to divide by 19. Okay, so the idea is if he raced 19 times, 18 times he loses, 1 time he wins. Okay, so then we'll go, remember this, now this is a probability, so we do want this one in decimal form. And we get 0.053, okay, or 5.3%. So if you see a horse like Bouncing Bubbles that has odds against of 18 to 1, it means there's only a 5.3% chance that he is going to win the race. All right. Let's do one more of these. Let's say squeaky wheel wins 62% of her races. Find her odds. Oops. We're looking at against. Okay, find her odds against. Okay, so odds against, remember, it's going to be failure over success. Now, we're in percent form, so this is the idea where we're going to have success is not just 62, it's 62 over 100. But if she has success 62% of the time, what's her failure going to look like? Okay, her failure is going to look like 38% of the time. So 38 out of 100 goes on top. Now again, like we said, normally those two denominators will be the same. So when you flip the bottom guy and multiply, those two denominators should cancel each other out. Boop, boop. Okay, and that is the case. Now also remember that we don't want to put that into our calculator, we want to reduce it. Okay, so we're looking for reducing here. And sometimes it's easy to see what the reducing is, sometimes it's a little bit harder, but I can tell that a 2 goes into each one of them. So if I take out a 2 here, there'll be 19 left. And if I take out a 2 there, there'll be 39. So it'll be 31, sorry. So only 19 over 31, or 19 to 31. So her odds against are 19 to 31. So 19 failures to every 31 successes, which means she does have more success, doesn't she? So failure to success means the success looks good. Okay, so this is a horse that wins more of her races than Bouncing Bubbles does. But here's the dealio. If you bet on Bouncing Bubbles and Bouncing Bubbles wins, you're gonna win a lot more. Okay, so remember what we talked about when we did that roulette thing. If you bet $1 on Bouncing Bubbles and he wins, you get $18. Okay, so over here though, if you bet $31, okay, they only then give you $19 more. So you're making money, of course you're making money, but if you bet $31, they're gonna give you 19. Well, okay, so you definitely get some money back, but it's nowhere near the payoff that you get when you're looking at a long shot, okay? So when the failure is far higher than the success. Okay, but that's what we're looking at when we look at odds in favor and odds against. So it means that you need to read the problem carefully. Ask yourself, have they given me odds in favor? Have they given me odds against? Or have they given me probability? Okay, so odds in failure, odds against, or probability. And you have to manipulate the problem to get what they're asking you for. So you've got to be careful with the way you read it. But it's really not that bad. Just making sure you read it carefully. Okay, sound good? All right, we'll come back with more.